So in this next section, we're going to use the break statement for finding primes, which is a bit more of a real world application, although all these primes have been found, and it's more for an example of the break statement. So let's start off with our for loop. So for n in range, and generally speaking, we're going to go, because we already know that 0 and 1, we'll call them primes, and so we're going to go from 2 to, let's say, 100 just as a tester. So that's our for loop. And then if we find a prime, we're going to need to have a prime flag. So we'll set something like a variable called prime, let's say prime underscore found, and then just say, let's say that's equal to false. And then if we find a prime, we'll set that equal to true, and that'll kind of like be our flag for breaking out in some way. So the next thing that we're going to do, so we've got this range, and we could print this range. Well, if we do print this range, it's going to be too large to see, but we're just in a range, and nothing's going to happen at this point. But we're going to count the numbers n, and it's going to start at 2 and go all the way to 100 less 1, so from 2 to 99. So the next thing to do is to test each item in the range. So we need another variable for counting. So we'll do for x, and then in range. Now we're going to go from 2 again, but this time we're going to limit ourselves up to the value of n, because if we are, say, at n equals 10, well, there's no point in testing beyond that. So from 2 to n. So that will be our nested. This is called a nested for loop. So we've got one for loop inside of another one. So we're counting one range on another one. Now let's place our test inside of the range. So we'll say something like if n percentage x. So, and that means if n divided by x, if the remainder of n divided by x is, if there is no remainder, so we're going to check if that's equal to 0. That means if there is no remainder, then we're going to say we found a prime, because they're divisible. These numbers n and x are divisible by each other without leaving any kind of remainder. So that indicates that a prime is found. So we need to change our flag, our prime found flag, to be assigned the value of true. So it was false, and now it's going to be assigned the value of true. And one extra thing that we're going to do, we could here print a statement saying that we could print something like n and then equals, and then x. So we could say n equals x times by, this is quite crude, but we can do it, times by and then n double divided by, because we want the integer part of it, and x. And at that point, I'll stick the break statement. I'll actually try and run it as well. So break. Let's do a break. We'll make this loop a little bit smaller. But just as a reminder, scrolling up a little bit over here, what we're looking for, we've got different types of divisions. This is our standard division. This is dividing two numbers by each other, but just extracting the integer parts of the two numbers, so throwing out the decimals. And this one here is dividing two numbers by each other, but testing to see if there's any leftovers, finding if there is a remainder. If they are fully divisible, the remainder will be equal to 0. So that's what all of that statement does. And then we will do over here, outside of this loop, if not. So if we haven't prime found, and remember that the not inverts the value of prime found. So if not prime found, then we could print. The IntelliSense is picking up the prime found, so print n comma, and then n comma is a prime number. So that's basically it, and we can have a little test of this and see if this runs. So we should get n is n equals x times by some integer value, otherwise n is a prime number. So let's have a little look and run it. We're only going from 2 to 10, so we can't do that much damage. So 2 is a prime number, 3 is a prime number, 4 equals 2 times 2, 5 is a prime number, 6 equals 2 times 3. So it looks like it's working. But we're just going to do one extra bit, and the key part of it is that we're able to break out, or at least it's not the key part, but we're showing how we can use the break statement effectively when a condition is satisfied, and this is a condition on line number 6. If that condition is satisfied, then we're able to break out of it. Now, this is one method of doing it by putting a flag up here and a starting flag here that's false, and a flag here to indicate true. And then test to see if this flag is true or not true. But an alternative way, or at least one extra bit that we can do is we can do answer, and this is just to show a little bit extra extra knowledge, shall we say, or extra awareness. So answer list, we're just making a list here, and we'll set it equal to a blank list. And the reason why is if we want to make this loop much bigger, then we're going to need to do a list, because if I like make this like 1,000, for example, and try and run the same piece of code, it's fine, it will run, but we get this output exceeds size limit, and that's because the output in a Jupyter notebook, it kind of won't let you go more than like 1,000 lines of like it's about 30 lines of code, so it puts ellipses here like ... after line number 26 or 25 or whatever the line number is. And then it goes to the end of the list, so we can't see our whole set of values. So, and that's because you don't want to like have to scroll down 1,000 lines to see it. So it's kind of like logical, and we're definitely not going to change this size limit, although we could do. But what we do instead is we're going to put this, we're going to put in this variable, which is an empty list, and we'll just populate that list instead, just so it's nice and we can see our list and we can check. We did a check for 10 and it looked like it was good, so now we're going to check for 1,000. It still looks like 1,000's good, so we're just going to eyeball through the numbers and see that this works. So we'll do answer list, and then we will do so instead of printing, we will append to our list. That's what we're going to do, and we'll append with an F string, because it's going to look a little bit cleaner. So we're going to make this an F string, and we'll say something like the number, just to keep it shorter, equals x times, and this is the nice thing about an F string, it just makes the language look a bit easier, n double divided by x, like that. And so we've done one appending over here. That's if the if we haven't found the prime, and I just need to check correct the spelling here, because that should be prime. And then if the number is a prime number, then we would also have to append our list. So we can now comment out this print statement here. It's no longer needed. And over here we'll do the same answer list, and we'll do the same thing, dot append, like that. We could have used dictionaries as well. There's lots of other methods. This isn't the most efficient method for finding primes. It's more an example of the break statement and a couple of other things that we've learnt. F for an F string, and then again n is a prime. So prime, let's spell prime correctly this time. So there we have appended the list in both cases, so we don't need the prime statements anymore. And we could, if we want to, now say that print here, print. Can't rely on the IntelliSense when you've got similar looking words, and then finished. Right, and then we run our piece of code and everything's done and it's finished, but we don't see anything. But we don't want to see anything, because we don't want all of that like bulkiness out of there. But what we can do is hit Control J and look at our variables here. We can already see it's being populated. So let's click on this link here. to open up our variables, and let's just expand this column a bit, and we can go through and we can see we're capturing all the primes. So like 14 isn't prime, or sorry, 16 isn't prime. Just note that these indexes don't relate to these numbers. They're actually 2 below the number, or 3 below the number if you count, because indexes start at 0. So 2 is a prime, 3 is a prime, 4 is not a prime, and so forth. So we get all of our primes, and we can sort of like scroll down the list, and we've got 1,000 of them in a much cleaner way. And obviously we could have output that as well to a file or something else. There's much better and more efficient pieces of code, but this is a great example for the break statement and how it works, and a good use case really. So a break statement in a for loop for finding prime numbers.